Hello everyone, Miss Hanley here. This is going to be notes number 7. It's about solving systems of equations using elimination. This corresponds with Unit 2 of Algebra 2, so you'll use this to help you complete Assignment 7 in your unit. Alright, so with elimination, just like with substitution, there are a few steps that we want to make sure we follow. Elimination is the third type of solving systems. So you've learned how to solve by graphing. You've learned how to solve by substitution. The third type is solving by elimination, and when you do that, you really want your equations to be in standard form. So go ahead and highlight that word for yourself so that you remember. Standard form is what we're going for here. And that's if you remember, ax plus by is equal to c. Okay. So we want to make sure our equations are in standard form and they're all lined up. And after that, we're either going to add or subtract the two equations together. And the goal is to eliminate or cancel out a variable so that you only have one variable left. Once we've done that, we can solve for the remaining variable and then substitute that back into the other equation. So let's take a look at an example and see. Alright, so you have the first two equations, 5x plus 3y is equal to negative 19, and 8x plus 3y is equal to negative 25. Now I've already told you that you're going to get one solution here. So remember, when you have one solution, that means you're going to end up with an actual point. So when I look at my two equations, I first want to make sure they're in standard form. So here we have ax by equals c, ax by equals c. And when they're in standard form, they're all lined up, and that's what we need to eliminate. Next, I want to decide which variable to eliminate. So you want to look at both the variables and their coefficients. With x, the variable is 5 and 8. So because those are two different values, that's going to take a little bit of work to eliminate. We can do it, but it's an extra step. With the y values, you have a 3 in front of both of them. So if we're going to actually cancel out a variable, we need to be able to add those two things together and end up with 0. Well, right now, if I add 3y plus 3y, I'm going to get 6y, not 0. So instead of doing that, I need to make them opposite signs. So I want the same coefficient, but opposite signs. And in order to do that, you can multiply by negative 1 to either of your equations. I'm going to choose the second one. It doesn't matter which one you pick, you'll end up with the same result. And then I'm going to rewrite this second line. So we end up with negative 8x minus 3y is equal to 25. Alright, and so I distributed negative 1 to each of those values, and now I'm going to bring down that first equation so that they're lined up again. So 5x plus 3y is equal to negative 19. So now let's watch what happens when we actually add these two lines together. And I always try and think of it as addition. So here I have negative 8x plus 5x, which would give me negative 3x. In the center we have negative 3y plus 3y. Well, that gives me 0y, but if there's 0, I don't actually need to write that. So those two just cancel out. And then on the right-hand side, we have 25 plus negative 19, which would give us a positive 6. So you can see that I have eliminated the y, and now I only have one variable. So all you have left to do to solve is divide by negative 3. And so we know that x is equal to negative 2. And remember that when you're solving a system, you need both the x value and the y value because we're actually making a point. So you want to take your value for x, negative 2, and substitute it into one of the original equations. Whether it be the first or the second, does not matter. So I'll just choose the first. So we'll have 5, but instead of x, I'm going to put in a negative 2 plus 3y is equal to negative 19. Negative 10 plus 3y is equal to negative 19. And so from here, if I add 10 to both sides, I get 3y is equal to negative 9. And divide away the 3, so y is equal to negative 3. So I found out that these two lines cross at the point negative 2, negative 3, and I did that using elimination. Okay, so now we're going to look at two equations that, when you solve them, result in an infinite solution. So I want to take a look here and go through our steps. So we want to make sure we have standard form, so ax plus by equals c, ax plus by is equal to c, and then we want to look at our coefficients, or the numbers in front of the variables. So in front of the x I have a 5 and a 10. Well, those aren't the same value anymore. So then we look to the y's. We have a 3 and a 6. You can still solve with elimination. Excuse me. You just have to do a little work before. So we need to make these coefficients the same. So you decide which value you want to eliminate, x or y. I'll just go with x, and it's not going to be any different if you choose y. You just will have, your process will look different, but your result will be the same. So if I need to eliminate x, I want to know, okay, well, what value does 10 and 5 both go into? Well, they both go into 10, so in order to make my top row say 10x, I have to multiply by 2, and I'm going to also multiply by a negative 2, because that will make it the opposite sign but the same value. So when you're doing elimination, you may have to multiply one line, you might have to multiply both lines to make them the same coefficient, but that will be a decision you'll make when you get to some more complex problems. So here we're going to distribute the 2 throughout our equations. We have negative 10x, we have minus 6y, and equals in negative 104. So I use that top row, and now I'm just looking at the second row and the third row. I've created a coefficient that's the same with the opposite sign, so I can add my lines together. So 10x minus 10x, well gee, that gives me 0. 6y minus 6y, that also gives me 0, so the only thing I have on the left is 0. 104 minus 104, that also gives me 0. So we're in a situation as we were with substitution where we get 0 equals 0. So you want to think to yourself, well, is that a true statement? Does 0 actually equal 0? Yes, it does. So if it's true, that's when you get your infinite solution situation. Alright, and lastly, we're going to solve a system that has no solution. So you can look at your two equations, just as we have been, and say, are they in standard form? So we have ax plus by equals c, ax plus by equals c. Now, just a note, if your equations are not in standard form, you're going to have to put them in standard form first. All three of these examples were already in standard form, but you may have to do some work before you can eliminate. Alright, so once I've identified standard form, then I want to look and see which variable to cancel. Well, the x, they have a negative 5 and a positive 5 coefficient. That's exactly what I want. Same number, but opposite signs. The y's also have the same value, but opposite signs. So let's check out what happens when I add these two together. I don't have to multiply anything because it's already set up. 5x minus 5x, well, that gives me 0 again. 6y minus 6y is 0. And then on the right hand side I have 45 plus 38, which is going to give me 83, I believe. And when I'm looking at this here now, I have 0 equals 83. Well, that's not a true statement, right? That would be false, that 0 equals 83. So if it's false, that's when you get the no solution situation. So just remember, elimination, you want to make sure they're in standard form first. If they're not, you have to make them that way.